around the world are assessing the damage following a massive assault by hackers.
The notorious hacking group Anonymous has declared war.
That hackers are stepping up their attacks to access private information and...
Hello and welcome to Winslow Academy. So in this episode of Python Cybersecurity, we're going to look at how we can use network data to make a visual representation in Google Maps of the traffic going through and from our computer. So as you see here, this is what we'll end up with today using our Python programming along with Wireshark and Google Maps. So first off, we're going to head over to Wireshark because we need to create our input data. So if you don't have Wireshark installed already, then I encourage you to do so because you will need this as the input data. If you are new to Wireshark and want to get used to how to use it, then I have a playlist that I will link to at the top right corner. But basically what you need to do is to, let's just close this, quit without saving. So I'll open it fresh here. So what you need to do is to pick an interface where you have network communication coming through. So I'll select Ethernet, and when I click this right away, it starts to capture packages from my computer. So let's just see, here it came. So I'll just stop this filter. So this was basically all I needed for now. I just needed some data. So I will stop my capture, which I have already done. Then I need to save it in a format that we can use to make our analysis in Python. So I will click File, Export Specific Packages, and here it's important that you select this Wireshark/TCP dump in PCAP format. So just select this one and save the file with the data that you have captured. So all this is the packages that has gone through and from your computer. So with this in place, we are actually ready to start the Python implementation. But I will also like to mention that this entire tutorial is in written format on the Winslow Medium page, where you will also find the links to the stuff you need to download and also the code. If you somehow get stuck doing this tutorial and don't want to write the code yourself, you can go here and copy the code and then start play with it right away. So this is another way of going through this tutorial. But before we go into the Python code, we need to download this GeoLite City because we need to translate our IP addresses into actual geolocations. Because if we don't have the longitude and latitude from our IP, we can't plot them into this Google map. So the way that we'll be downloading this is to use this GitHub link right here, which will put us over to this site, and here you can just under code download zip. So this is basically all you need. You need this geolitecity.dat. So once that's in place, we are finally ready to go into. So the first thing that we're going to dive into is the main method. So the main method is where we open the data that we have just captured. So the wire.pcap file. So the one we have right here. And that is the one we saved from Wireshark. So we are going to open this, and we need to open this in binary format in order to be able to read it as intended. So we'll be using this dpkt library. So we are importing these three right here. So dpkt, socket, and pygeoip. So what we'll be doing is to create a KML file, because KML files is something that we can input to Google Maps. So this is basically just a format that Google knows how to read. So in the main method, we'll be creating the header and the footer of our file. And then in the rest of this method, we're going to create the content of the file. So basically the body. So first off, we're going to define that this is simply just XML format. We are going to make some styling. So this will be the styles that you see right here. This is the red color here and the width of the lines. That is basically what is being styled right here. So if you want a thicker line, just change this one. If you want another color, you can change this one. Or if you want further styling, then just Google how to style these KML files in a supportive way of Google Maps. So this is what is going on in this KML header, and in the footer we're simply just closing off some of the tags that we opened up doing this file. So what is actually interesting here is what we put into the file. So the content of the file is going to come from this plot IPs method, where we are inputting our file that we have opened and captured. So we are putting this into the plot IPs method. So this is the method we have right here. And here, first off, we start with an empty variable, so there is nothing yet. Then we're going to loop over each of the packages that we have captured, and then we're going to try to fetch the IPs. So we want to fetch the source IP and the destination IP, and that is because we want to be able to create these lines right here, such that we have a source right here. So as you see, this is the source from my computer, and then out to the destination on a different service that I hit doing my capture. So the source and the destination to be able to create these lines. So that is what we capture right here. And then we are going to put these into our KML body builder method, this red KML right here. So we have the destination from our socket, where we put the IP of the destination and the IP of the source. So if we go up to this method right here, this is where all the magic is happening, more or less. So this is where we translate the IP addresses into actual geolocations. And as you see, I have put in these X's right here, and that is because I have hidden my own IP. So when you are copying this code, remember to look up your own IP and input this as the source IP. As you see here, this input of the source IP is not being used, and that is because in the current format of this application, we have captured the internal IP, so the IP that my specific device have on my own network, meaning that it is not the IP address that is visible from the internet, so the outside world, meaning that we can't put a geolocation on an internal IP because nobody else is knowing this IP except from my own personal router. So in the way that I have implemented this is just by going to what's my IP, look up my own public IP and input it right here. If you want to extend this, you could, for example, make it such that you, instead of your internal IP, get your public IP to automatically fetch this. But in this example, we have just manually inputted it as the source IP, and that is why this is not being used. So if we go further here, we are going to another try method, and this is where we are going to get the longitude and latitude. But the important part that you have to remember is that you also need to use this database, this geolightcity.dat file. So this is the database consisting of all the geographic locations that will be matched to our IP addresses. So what we do here is to, first off, putting these into the variable, so we get the record by name, and by name we are taking the IPs. Then we fetch the longitude and latitude, first for the destination, which is what we have captured and has been passed into the method. Then we take the longitude and latitude for our source IP that has been manually put here as a static variable. Then we go into the KML record, where we are going to create the record for that particular destination IP. So first off, we just specify that we have a place mark right here. So we open this with this tag. Then in the name, we are going to input the destination IP. This means that the name of the point in Google Maps, if we go back right here and click this, oh, maybe I'll just click it here like this. As you see, then this is the name. So the destination IP of this particular line is this IP right here. So this is not my IP, but the server that I'm hitting over in USA. So this is the name that we are inputting here. This destination IP is getting put into the name field. Then we have the styling right here. So this is where we just point to the styling object that we created in the header. So this one right here, trans blue poly. And this is just a name, so you can change this again if you want, but that's up to you. Then we go into the interesting stuff. This is where we have the line string right here. So this is what tells Google Maps that we want a line instead of just a plot point. So if we, for example, used another KML tag here, we would not get these lines that we have from our source to our destination. So in here we put the latitude, the longitude and latitude first of our destination. So this is the variables right here. We input into this field here, and then we take on the same in the same tag. So these coordinate tags, we input the source, longitude, and latitude as well, and then we close off these tags and return that object. And that is basically what we're doing for all the package and all the traffic that we have been captured. So we are just looping over this in order to create a lot of these place marks right here. So if I try to run this, I will just execute it here. And as you see, since I have implemented this with a print, it will just be printed to the console. So we have a lot of stuff right here. And what we need to do is just to take this. You could also extend this code by just having it make the file yourself, but I will just copy this right here and open up Notepad++, and then I simply just have to copy paste this in, remove this process here, and then you need to save it as a KML file. So just the extension of the file is .kml, and then all the rest should be in place to put into Google. So all we have to do now is to save this. Then we head over to Google, and I'll just click here and say new card, just to illustrate this. So here I will get a new card, and the way that you get into this, of course, is by, I will just show you here. So remember that it is a good idea to read this article as well to get the technical links and just to follow along. So this video is a quickly overview of what has been done, but I encourage you to also visit the article. But you need to navigate to google.com/mymaps, and that is the page I'm on right here. So I'm in a new map right here, and that allows you to import these KML files. So I will just click on import here. Then I will select a new file, and this KML sample.kml. And once this is uploaded, Google Maps will automatically display my particular traffic. And as you see now, this has changed, and that is because we just generated the file using this xxxxx, and that kind of messed up the source of the file. But if you input your own IP, you should see that the pointers will start on the specific location that you are located and then point out to the world based on what servers you hit during your capture. So this was a quick video on how to use Python along with Wireshark and Google Maps to create a nice visual representation of the network traffic going through a device. So remember to like and subscribe, and then I will see you next time here on Winslow Academy. Hello and welcome to Winslow Academy. So in this lecture we are going to look how to build a simple port scanner using the Python programming language. So what we are going to actually accomplish is to make a simple scanner that will take a given address as input, an IP address, and then a list of ports, and then it will try to make a TCP connection towards that port and look for a response, meaning a TCP acknowledgement response from that particular server. And if it gets such a response, we know that this port is open on that particular server. Port scans are used frequently when you are doing forensic analysis or penetration testing, because you can then look for vulnerable ports that are open on that particular server. So what we're going to do here is first off going to do our imports. So we are going to import everything from the socket library here, and the part I have here, if name equals main. If you're familiar with Python, you know that this is just for being able to execute this code directly by from this point, but you can also make it usable from the command prompt by using the opt pass by simply importing this right here if you want this, but we'll just stick with being able to execute it from here. So next off, we're going to define the first method that we are going to create, which we're going to call connection scan. That is going to take as input a target host and a target port. So this will be the main method that basically try to make the connection. So it will only take a target host and one single port as input, because we will afterwards define the method that will loop over this with a list of ports. So we will make a try where we say that the connection is going to be made from the socket, where we'll use it fint right here, and the sock stream. Then we are going to define that this connection is going to connect, and it is going to take the target host and the target port, which is the ones we want to use for trying to make this connection. Then we are going to print the result of this connection if we get an active connection. So we are still within this try catch clause here. So we'll say print, and then we'll just define this as a positive case. So we'll be using this plus right here. We'll be using in the except part, we'll just add a minus. So this is just a textual representation, and nothing functional is about this. So you can define something else if you want to. But then we'll just define that if this is going to get printed, we will be saying TCP open, and the particular port that is open is using this %d, and we define this by saying that this is supposed to be from the target port. So it will just take the value of the target port and insert it into this text string right here. Then we are going to say that this connection is going to close itself, because we are then done with that connection. Then we are going to make a except here should we be unable to make the connection, where we simply just copy this part right here, and as mentioned, instead of a plus, we'll just have a minus, so that it is easy for us to recognize whether there is a positive or negative case. And instead of open, we will just say closed, because we are not able to make a connection within this try block here, so the port is considered closed. So let's try to call this method. So we'll say const scan, and then we'll be inputting IP address for now, because we have not yet created the method for translating the host name. So we'll just do a quick ping to Google just to get their IP. So we'll input their IP right here, and then we'll just try to call over port 80, which is commonly used for HTTP connections. And let's see what happens when we execute this. And as we see, port 80 is open. But if we try, for example, some of the other ports, it will spin a bit, and once the timeout has been reached, it will print that this port is closed, because Google, the server on this particular IP at Google, doesn't allow us to access this port. So this was the first method that we were to define. Next off, we're going to define the actual port scan method. So we'll call this port scan, and let's just make a space right here, and this will take in again a target host, and then it will take target ports this time, because we want to input a list of ports that we want to scan instead of calling this over and over again. So in here we'll say try, and then we'll try to translate this host name by getting its IP, such that we don't have to do this manually inputting the IP. So we'll say try, and we'll say target IP equals get host by name, and then we will say target host, and then we will say accept. If we are not able to accomplish this, we will just make a print statement where we will be reusing this logic here, but we will just, instead of doing this, we'll just say cannot resolve, and then we will use this right here, and instead of target port, we will be using the target host like this, and then we will simply just do a return, because we just want to get back to this here, since we cannot resolve this particular host, and since we are not able to translate this, there is no reason to loop over these ports. So we'll make a try here, given that we have this IP, so we have not been into this except code here, and we will say target name equals get host by address. So here we are going to get the host name from the IP address, and from here we are going to input this target address here. And we'll be doing this print statement, and we'll say plus here instead. And we are going to add a new line such that it will, once we are looping over this, it will not be printing it on the same, but we will jump to a new line each time. You will see this when we execute it. So we say here that we are now scan result off, and here we say target host. Oh, we want the target name not there, like so. And here we again have except given that we are not able to do this part, we will just say that it has to print. So we'll just copy this, and we'll say scan result of, and instead of this we'll be using our target IP right here. So now we have our print case for both scenarios where we have the target name and of the target IP. Next off, we are to set a default timeout such that we only do this once a second, and then we will loop over. So now we're going to call this connection scan for each of the port we have given as a list right here. So we will say for target port in target ports, then we will say print scanning. Oh, we need to do so. Scanning port, and then the target port. So this particular element in this list of ports. And here we're going to call our previous defined method, this one, where we will give our target host and our target port by saying integer of target port, like so. So now we have the actual code needed. So now it's just about to execute it. Whereas instead of calling connect scan, we'll be calling the port scan instead. So we'll be calling this port scan here. So we'll say port scan, and then we will try by saying google.com, and then define a list of ports. So we'll say port 80 and port 22, and let's see if we execute this. Oh, and it's seen we copied the print statement one too many, so this is actually string. So we'll be doing like this. Oh, and this of course is not a string, this is an integer, so we will just do similar to what we did here. So we'll say like so. And as we now see, the result here of our code. So first off, we are scanning a result of this, which got resolved from google.com to the particular domain name of the server. And then we are first off scanning port 80, and this port is set to be open. Then we are scanning for port 22, and this port is closed. So this is a simple port scanner using Python, and now we can basically call any given address and input any valid amount of existing ports out there, and just try to see if these are open. So I hope you liked the video, and then I'll see you next time here on Winslow Academy. Hello and welcome to Winslow Academy. This is part 2 in our Python cybersecurity tutorial. So in the last lecture we saw how to make a simple port scanner, and in this lecture we're going to make a scanner that allows us to scan a given host name for anonymous FTP connections, meaning that some web servers allow that the users connect to them anonymously, meaning that you can just input anonymous as the user and then get access to the given file share on that server. So first off, we're going to import the FTP lib, and then we're going to make a simple method that we call anon login that is going to take in the host name as input, so the IP of the server. Then we're going to make a try catch. Here we're going to define the FTP, so it will be the FTP lib / FTP, and then we're going to take the host name. Then we're going to say ftp.login, and we're going to try to log in using this anonymous connection. And if you, for example, go into this login here, it also has set up the code such that it also checks if you're using this anonymous as the user, then you don't need to use a password, because it will then try to use this anonymous feature on that particular FTP server. So following this, we are going to print, and we are going to say new line, and then we simply just say plus if we have an active connection. So we say string hostname, so this is the IP that we are going to put in, the hostname, and then we are going to say plus FTP anonymous login succeeded. So this is basically all we need in our try. Then we are simply just going to return this, so return true in case that we log in. So next off, of course we also need to quit the connection once we have logged in like this. Next up, we're going to have our accept, so we're going to say exception, and then we simply print. And here we're going to print similar to what we did up here. So I'll just copy this, and we will just say a minus here, since here we are not getting an active connection. And instead of succeeded, we will say fails right here. And then we again will return, but here we're going to return false. So this is basically all we need in this simple method. So we are going to call this method once for one host name, but you can easily automate this by looping over a list of servers to check the servers if they have this connection. But we are just going to call one particular server. So we're going to call the method anon login, and for the host name we're going to use this speedtest.tail2.net, which has different ways for you to test your internet connection. Among them is this FTP that allows you to log in anonymously to just check your upload speed and download speed. So we take this here, and since we haven't made a DNS lookup in this method, we will just get their IP and then we take this as the host name, and we're going to input this as a string, and let's try run our method. And as you see, we have a plus. So on this host name, the FTP anonymous login succeeded. But if we're going to try another destination, I'll just randomly switch one of these just to get a negative case. Hopefully I will hit something that fails here. And as you see here, when using this, the FTP anonymous login fails. This could be because there is not running a FTP on this connection, but also it could be that there is a FTP that does just simply don't allow us to use this anonymous login. So this is a simple way to scan your web servers for anonymous FTP access. So remember to like and subscribe, and then I will see you next time here on Winslow Academy. Hello and welcome to Winslow Academy. So in this part 4 of our Python cybersecurity, we're going to make a little script that allows us to use a dictionary password attack on our encrypted zip file, which means that we'll be creating a script that uses a pre-made list of passwords to just trying to brute force an encrypted zip file. So first off, we're going to import the zip file, library. And next off, we're going to create one of two methods. So the first one is the one where we actually tries to extract the content of our zip file, and that will be taking two inputs, so the zip file itself and the password that we want to try to use to extract the file from within the zip file. Next up, we're going to make a try, and then we will just try to say zip file dot extract all, and our input for this is going to be the password that we gave as input. So we take the zip file and we'll try to extract the file from within using this password. And if we succeed, meaning that we will not get any errors, which means that the password is correct, we will just return password. And then we'll make an except saying return, meaning that we'll just return false and nothing if this give any error. And this will give an error every time we try a wrong password. So we'll just make a method now that will allow us to loop over this extract file and try all the passwords from our list. So we'll be making our main method here. Here we're going to say that our set file is equal to set zip file dot zip file here, and then we're going to name the zip file. Now I haven't made the zip file yet, but I will just name it test.zip, and we'll make it in a second. And then we are going to say pass file, which is the file that is going to contain all the passwords that we want to try in our attempt to brute force this zip file. And we'll just call this passlist.txt. Then we will say for each line in our pass file, we want to read the lines, and then within this we'll say that the password of the current iteration is equal to the line where we'll just strip off the new line encoding right here. So this will allow us to take a line and then just skip this new line. And given on this, we'll say guess equals to our extract method here, and then we're going to input the zip file that we have defined right here, and then the password of this iteration. So we'll loop over this for all passwords that are within our password list. Next up, we're going to say if our guess is true, meaning that we have hit this one, so we have been allowed to extract the files, so we have returned a password. If this is the case, we will just print to the console saying that password equals, so we'll just say plus password, and then we'll just break out of the loop after we have executed this if statement and printed the correct password. So now we're actually ready to run our file. Oh, I forgot this. So now we're ready to execute this, but first off we need a password list and we need our encrypted zip file. So first off we're going to create the pass list file list.txt, and in here we can just type any kind of, so we'll say Thomas password 1 pass123 admin, and for now we'll just stick with these 4, and then we'll try to run the script without having the right password. But first off we just need to make a zip file, so we'll just say open explore, and it came right here, and then we'll just define a text and call this test, and now I'll just add this to an archive. I will say zip file, so now this is test.zip. If you have some other files that you want to zip, just be sure that the name you give the archive is the same that you described in the list, and we'll just choose this zip legacy encryption, and then we'll say the password is to be test123. Then we'll click OK and zip this file. And now if we open this zip file, we'll see that we can see the file, but if we try to actually open it, we are required a password, and if we enter the password we are allowed to see it, so test123, and we are allowed to see it. But if we enter a wrong password, we get an error saying that the password was not correct. So now we actually have what we need, except from that the password that we try to use here is not in the right format. So we need to have the right encoding of this input right here. So we will say bytes, and we will take missing S bytes, and then the encoding is to be UTF-8, and then we'll close off this right here. So now I'll try to execute this, and I have already defined that in this if name main that we're going to execute this main method right here. If you haven't done this, you just need to apply this in order to execute it. So we'll run main, and as you see, now we have finished and nothing happened, and that is because we actually didn't have the correct password in our pass list. So our dictionary tag script here just took our 4 passwords and looped over and saw that none of these were returning something that it could use, meaning that error was cast here due to the wrong password. So we just keep hitting this one here, and we could just, to test this, just say wrong pass, and if you run this again, you see here 4 times wrong pass. And now we'll just stick with this and insert the right password in our pass list. So we will say test 1 2 3, and now I'll just delete this just to illustrate that it is actually also getting opened when we extract this. So now we only have the zip file, and now we have entered our test 1 2 3, saved it, so we have 5 passwords. We'll execute this, and as you see, the test.txt file came once again because we were now allowed to extract the file from within the zip file, and as expected, our line right here got executed saying that the password was test123. So if you have an encrypted zip file, then you can try to search online for these password lists. There are many lists out there with several thousand, even millions of different passwords that are popular to use for different accounts. So you can just use these password lists to make this kind of dictionary tag on a file that you have saved on your own machine, meaning that you can try an unlimited amount of time. So it's only up to your computing power. It's basically that which decide how fast and how many times a minute that you can try these passwords. So this was all for this tutorial. I will see you next time here on Winslov Academy. Hello and welcome to Winslov Academy. This is part 5 in our Python cybersecurity. In this video we're going to look at how we can use Python programming to scan our system for deleted files. This script right here is already coded, as you can see, so I'll just try to execute this to give you an idea of what the end result is. So if you run this, here you see that we found some deleted files. We get file type, and we have also listed which operation system user that has actually deleted this. So we have a system profile and we have the main user Alfred, and then the files that has been deleted by the given user is listed afterwards. So this can be used to do forensics analysis on a system if you want to see if a given user has tried to delete some files, and then you can probably try to recover these files. And then you will know who tried to hide something if there is a file of interest. But let's dive into this script right here. So the first thing that we need to pay attention to is this return directory right here. So the script here has been coded in a way that it optimally is operation system independent, meaning that we will have 3 different locations where we try to scan for these deleted files. So we will look into the files that has been recycled in the recycle bin. Next off, once we have found a given location that is valid based on the operation system that we are running the script on, we will return the correct path to the deleted files. So the main method that is actually going to do the logic for us is this find recycled right here. So first, we execute recycle directory to find our to return directory where we store the end result in our variable right here. Then we give this path as input to our main method, which is called find recycled. In here, we will use our operation system to dive into this folder, and then we will tell it to look for all the files that is available in here based on the system user ID of a user. So first off, as you see right here, we see the listing files for user and then some long UID right here. That is actually a user ID that can't be translated, even though we tried like we did here with Alfred. So if we just tell the system to go through the deleted files based on users without doing some user translation, this is the ID that we'll get for all users available. But since we would like to know exactly the name of the user that has deleted a file, we have implemented a little method called isID to user, and that is the method that we call right here. But first we list based on the original ID. We list the files that has been deleted using this OS list directory right here. And then basically we just loop over these and print them out in their names right here. So we have the found files, which is the print line right here within this loop that just loop over each file found. But the user that we are printing, so for example Alfred, has to be translated first. So that is what's going on in this top method right here. So in here we actually use the Windows directory to look at the user information, so that we can try to translate each SID into a username, and then that will allow us to print this user here, which is much more useful for us instead of this ID right here. So we'll go into this method where we use this Windows register, where we take the Windows register key. We have the local machine here, so we take the software Microsoft Windows NT current version profile list. Then we append it with this SID, which were originally ID like this one right here, and then we take the profile image path, and based on this we are actually allowed to look up this ID and see if there is a valid readable username available. If there is, we'll take this username, we will do the appropriate split based on where this particular user is in the file. So if you change this, for example, we can try to say -2 and just execute this. Then we see that we only get, for example, users and config, because now we're actually splitting in this returned path in the wrong way. So by using -1, we are in the exact location where the particular username is to be placed. Then we will be returning the user value if one is found. If not, we simply just default back to this SID, which is why we see the SID right here, because we couldn't find a valid user for this particular one. But we found one for Alfred and one for system profile. Based on this, we can get back to the main method, where we just take this user and print it before we loop over all the files that has been found for this particular user, which is happening in this first loop right here, so the outer loop. And this is basically all the methods that you need in this particular script. So you have 3 main scripts. One that returns the directory path based on the operation system. Our main logic method that will loop over the files found in that particular directory based on the users that has been operating and deleting files. And then you simply just do user ID, system ID translation to username. And based on this, you can create this main method, which just combine the return of the right directory and give us an input to our main logic file. And that is basically all you need to have this script running. If you are running this right out of the box, means that you will just write the code here and then try to execute it, you might be prompted with Windows saying that you do not have access to the particular path that has been found on the operation system. So you might need to run either the terminal or the IDE that you have been coding it in. For example, this is PyCharm. I have to run this as an administrator before Windows will give me access to look up what files has been deleted. So this was all for this video, and then I will see you next time here on Winslow Academy. Hello and welcome to Winslow Academy. This is part 6 in our Python cybersecurity. In this lecture, we are going to look at how we can make a brute force function that will allow us to try to brute force a given FTP server. Meaning that we'll take a username and log in and just try all combinations in our password file and just try to log in until we hit a login that matches the FTP, an active user on that FTP. Of course, if we don't have the exact username and password in our password list, we will not be able to crack it. But we will follow a similar approach as we did in part 4 on in this series, where we made a zip password cracker, which was also based on a dictionary brute force attack approach. So first off, we're going to import this FTP library, and we're going to create our main method. So we'll call this brute force login. This will take in a host name, where we'll define the host name for the FTP server, and then we are going to say pass list equals open, and here we're going to open this password file that we gave as input, and we're going to open it in read mode. Next off, we're going to loop over each line in the file. So we'll say for line in pass list dot read lines, and here we're going to first get the username. So username equals line dot split. We'll create some content and also the file in just a second, but first we'll just write this main code here. So we're going to take the first element on that line, so we'll start at index 0. Then we'll take the password, and we are going to say line.split. Again, we are going to split based on this colon here, and then we're going to take the next element, which is index 1, and then we're going to say strip, and we will say r dot strip, and then new line, like so. Then we're going to say print, and then we'll just be printing saying plus trying, and then we'll say plus string username plus, and then we're going to say slash, and we'll see how this looks in just a second, and then we say string password. So now all we do is just to loop over a given file. So we'll just test this first before we add the actual functionality to connect to the host. So here we'll just define 123. We're not using this at the moment. As password file, we define where to look at this. So we'll just say here password file equals credentials.txt, and we'll just create this host name equals, and currently we don't have one, so we'll just say 123, and then I will just replace this just so our code is ready for the next step. But here we will input our password file, and then we need to create this, and we need to do this in the root folder where our file is, because we have just defined that it is in the same directory layer. So we need to call this credentials.txt, and in here we need to make it such that we have these colon between the username and the password in order for this part of the code to work and be so that we are able to look at the right indexes. So here we could say admin, we could say admin pass, we could say admin 123, just to have something to test. And then we go back here and execute this. And as you see, this went very quickly because we don't do any actual connection to FTP, but we printed out here that we have been looping over each line. We have located the username, we have located the password, and we are here just printing what iteration we are currently at, so what credentials we are actually trying right now. Next off, we need to add the actual connection part of the FTP, so we'll say try, and that has to be within the loop because we are looping over each line. So for each line in the file where we have a username and a password, we need to try make a connection, meaning that we'll try to log in. So we'll say FTP equals FTP lib dot FTP, and then we'll give in the host name, which we gave as input parameter, which is the one defined here that we gave passed into this method. So this is our host name, so we need to make this an actual FTP or provide an IP where there is an actual FTP server running. Then we say FTP dot login. Here we provide the username and the password, and then we just say print, and then we say then we say like this, and then we say FTP login succeeded, and then we say plus, and then we just define our username again, just to have it write the username and password on the same line when we have an active login. We will of course also be printing it like trying, but then we also will have a line saying we succeeded with that particular password. And again, we will just be copying this part here, so it will be a similar line that we print. Next off, we need to quit this FTP if we have an active connection, because then we know that we have now found the password, and we can then log in using other ways than this. This is only for trying to brute force our way in by finding the password, and then we will simply just say return username and password, and here we say except, so we have an exception, and we are going to say exception E, and then we are going to say pass like this. And if I now try to run this, as you see, we are now trying admin, we are trying admin pass, we are trying admin 123, but we never succeeded. You could also make like a print line here that just print out that we unsucceeded, but that's up to you. Now all there is left is to provide an actual FTP IP in here. So I will not be providing one here, because you should never brute force an FTP server that you don't own or don't have the access rights to play with. But you can set up one yourself, either on your local device, or you can set up one up online and then just try to play around with it using this method. So this was all for this tutorial. Remember to like and subscribe, and then I will see you next time here on Winslow Academy. Hello and welcome to Winslow Academy. So this is part 8 in our Python cybersecurity. In this episode, we're going to look at how to make a simple method that allows us to crack simple hash passwords. So what is a hash password? Basically, whenever you are typing in a password on a website, if that website is of any quality at all, it will probably not store your password in its raw value. So let's say that my password equals admin, then that particular web application that I'm using should never just store this password as admin, because if they at some point get a breach to their database and someone gets to extract this value, then they can basically log in using my account because they know my password, and if I have been stupid enough, they can try to use this password on some of my other accounts as well. So that is the reason why you should never use the same password on multiple services, because that can actually happen, that people get access to your password. But in most cases, web applications will store, or services in general will store your password in a hashed value, and if they are taking their security seriously, they will also include a hash value, a salt value, but will not go into details about this, but focus on this simple hashing cracking method that we'll be doing. So let's say that this particular service has used the MD5 hashing algorithm to hash my password. then we will get a value similar to this we have right here. So when I enter my password, they will create a hash value of it and then store this particular value instead. And once I try to log in, they will just take the same algorithm, use it on the password I tried to enter, and if that hash value that comes out of this matches what they have stored in the database, they know that I have entered the correct password. This also means that if any malicious user get access to the database, they will only have a lot of hash values and not the password in its raw format, meaning that they cannot take this value and then use it as password, because that will not generate the exact value right here, but a total different hash value, because the algorithm will calculate it based on this value, since it does not know that this is a hashed value. So what hackers are doing when they get access to a database of hashed password, they need to crack as many of them as possible. And a simple way of doing so is simply just to use a dictionary attack, meaning that you will have a file of raw password values that you then run all the hash values that you have against to see if some of these matches. So this method is doing exactly this. So we have a simple method right here, crack hash, where we give it an input password, which is this hash value that we say that we have gotten access to. Then we will in the method, first of all, try to open our pass file. So this is our word list of words. So this is the file I have right here. I have just inserted 4 different passwords just to illustrate this, but you can actually go into GitHub and find some major password list that consist of more than 10,000 words that you can use in such a script like this. Then we will just have a simple except if there something goes wrong in our attempt to open this file, where we'll just print could not find the file. Then the main logic of this method is this for loop right here. So we will go through the list of words in our word list, and for each word, so each possible password, we will first off encode it using the UTF-8 encoding, and then we will take the encoded value of the password in the list. First off, we'll be removing all empty spaces, either in the middle of the word or at the prefix or postfix of the word, before we then get the actual hash using this MD5 hashing algorithm. And I will just mention that this is not a particularly good hashing algorithm. So if you want to use this for trying to be more effectively using these, you should try to use several different hashes, because then you will have a bigger success of cracking this particular hash. Of course, this is only a MD5 hash, but if you get access to a hash sentence or string and you are not sure which hash algorithm to use, it might make sense to include more of these hash algorithms here when trying to do this, but we will just stick with this MD5. And then we simply just make a if statement where we take our new hash value and compare it to our input hash, and if these match, then we know that this word that we are currently looping over is the password that is used to generate this particular value. So let's try to execute this and see if this hash is existing in our list here. I know it is because I created it, but let's try to run this, and as you see here, password found, and the password was pass. So this particular string right here generates this hashing value when using it on the MD5 algorithm. And that is basically how you can make a simple script that will use this dictionary attack approach to try to crack hash passwords. I hope you enjoyed this video, and I will see you next time here on Winslow Academy.